Everybody. Today we're going to talk a little bit about vectors and vector addition. And you are going to get to experience this a little bit in lab. You are seeing this already in projectile motion. And, well, I'm sorry, I'll take that back. You're not going to really experience it in lab, but I gave you a simulation for you to look at and play around with. And I attached a bunch of questions with that simulation, but that's not something that you have to do unless you really want to do that. If this idea is confusing to you, then by all means go and play around with that simulation as much or as little as you need to. So, without further ado, vector addition, and let's get started. All right. What is a vector? The basics of a vector is a magnitude and a direction of some quantity that's measured. So I have a car that's driving, and it's driving at 50 kilometers an hour, but that 50 kilometers an hour is the speed, not the velocity, and so that velocity has to have a direction. So we're going to say 50 kilometers an hour forward. And the vector itself, I'm going to change colors just so it stands out, is this arrow. And so this arrow right here is the vector, and its direction is telling us, is that positive, is that negative, is that forward, is that backward. It tells us a bunch about that motion or that force or that whatever quantity you happen to be measuring that is a vector that requires a direction to go with it. So that in a nutshell is what a vector is. You've seen them in your projectile motion problems as a ball was hit at some angle. Let's say it got hit at 25 meters per second at 20 degrees from the horizontal, and then you saw that you had to turn that into an X and a Y in order to find out what's happening with that motion. This is a little bit broader than that, and this is just an introduction to all vectors and how we add them or subtract them or whatever we might be doing with them. So some of this will be applicable to projectile motion, some of it's going to have to wait a little bit to be applicable later on. But I did want to introduce you to this idea. All right, so vector addition. In a scenario, whatever our scenario might be, all of the vectors, which measure the same quantity, have to add together to give the overall total effect. So I have a car driving at 50 kilometers an hour, but there is a wind blowing perpendicular to the motion of the car at 15 kilometers an hour. So I have two different things that I'm measuring, both velocities, and they're both affecting the object I am measuring. And I have to add those two pieces together in order to find out what is truly going on. So how do I do this? I do this by doing something called adding these vectors tip to tail. I choose one of them, and I'm going to choose the 50 kilometers per hour and say, all right, I've got that one, and I'm going to add my second vector, my 15 kilometers an hour, to the tip of that. So this is the tip. So the tip is the arrow portion, and this is the tail. And I added my wind vector. The tail of it went to the tip of my original vector, and my car is now going to follow a path that's not the 50 kilometers an hour forward or the 15 kilometers an hour down or perpendicular, but it is going to follow a path that is the resultant. It is the sum combination of my two vectors. So what would that resultant be? Well, that's the fun of vector addition. And to find that resultant, we need to use Pythagorean theorem. And I'm just going to set these up. I might solve them, but I know that to find my hypotenuse, I have to do a squared plus b squared equals c squared. And my resultant is my c. And I'm going to just rewrite this shorthand. So c equals, I'm going to take the square root of both sides, the square root of a squared plus b squared. And I can do that. I can square 50, I can square 15, and I can add those two values together and then take the square root of that to find the magnitude of my resultant vector. And you're going to have to do this when you get into, you had some velocity in the x direction and some velocity in the y direction, and you're going to have to add these together to find the overall total velocity, vt. And how you would do that the same way I just described this, using Pythagorean theorem. So that's what you're going to be doing in the next week or so with your projectile motion problems. All right, so here that is, the square root of 50 squared plus 15 squared is 52.2 kilometers an hour. But wait, that is not the final answer, because vectors have a magnitude, a value, a number, magnitude, and direction, plus direction. So how do I find the direction that this resultant is going? And to do that, I'm going to use sine, cosine, and tangent, or tangent, one of those three. And how you remember those is SOHCAHTOA. So sine is the opposite over hypotenuse. Cosine, ka, is the adjacent over the hypotenuse. So if I'm trying to find this angle, my opposite is the one opposite that angle. So this would be my opposite. This one is my adjacent. And then my hypotenuse is always the long leg. So if I want to find that angle, I can use sine. If I know the opposite in the hypotenuse, I can use cosine. If I know the adjacent in the hypotenuse, or I can use tangent, TOA. That is where you have the opposite over adjacent. And in this case, since both of those are the numbers given to me, I didn't do any math with them. I chose to use tangent. And you might be like, hey, Mr. Kaufman, why is this negative 15? And it is negative 15 because that 15 is going down. So on your coordinate plane, we often just say that's positive, this is negative, this is negative. And if I have some vector going down, it's going negative 15. And I went over some 50 kilometers per hour. And so what angle is this? Well, tangent of my angle. So that's my unknown. Let me erase some things here. So I've got some things I don't know. Theta. So tangent of theta, my unknown, equals the opposite, 15, over my adjacent, 50. And for me to solve for theta, I have to get that tangent to the other side. And to do that, I do the inverse tangent, tangent inverse of 15 divided by 50. And that gives me this angle up there of 16.7. And if I use the negative 15, it'll give me an angle of negative 16.7. You could also say 16.7 degrees south of west, or south of east. So south is down, east is to the right. So my final answer would be 52.2 kilometers per hour at 16.7 degrees south of east. So to do vector addition, you're going to need to know a little bit of trigonometry, nothing more than sine, cosine, and tangent, and solve for angles and Pythagorean theorem. So that is the basics.